Part A, given that 2 cos x plus 30 equals sine x minus 30, without using a calculator, show that tan x is going to equal 3 root 3 minus 4. So I'm going to expand both sides of this using the addition formulae. So we'll start off with 2 lots of bracket. Right, using the cos addition formula, I'll get cos x cos 30 minus sine x sine 30. Close the bracket, that's the left hand side done. Now using the right hand side, expanding this with the sine addition formula, we'll get sine x cos 30 minus cos x sine 30. Now, I know that cos 30 is equal to root 3 over 2. It's one of the exact values you're expected to know. And I also know that sine 30 is 1/2, sorry. So let's substitute those into this expression. So we'd get cos x times root 3 over 2 minus sine x times 1/2 equals sine x times root 3 over 2 minus cos x times 1/2. Now on the left hand side here, when I expand this bracket, I've got the 2, which is when I multiply through, that's going to cancel with this half here and this half here. So the left hand side then will be cos x times root 3 minus sine x. And on the right hand side, I've got the root 3 over 2 sine x and the half cos x. Now, I don't particularly like these fractions here, so I'm going to multiply both sides by 2 just to get rid of those. So multiplying the left-hand side by 2, I get 2 root 3 cos x minus 2 sine x equals root 3 sine x minus cos x. I'm now going to divide both sides of this equation by cos x, because I know I'm trying to end up with a tan x. So if I divide through by cos x, that will cancel. This will be divided by cos x, this will be divided by cos x, and this would cancel just to be a 1. So that's going to leave me with 2 root 3 minus 2 tan x equals root 3 tan x minus 1. I'll now move the tan x's so they're all on one side and move the numbers so they are on the other. So I'm going to move this minus 1 over to the left hand side, and I'll move this tan x over to the right hand side. So get 2 root 3 plus 1 equals root 3 tan x plus 2 tan x. I'm going to factorise the tan x outside, and then I'm going to divide both sides by the root 3 plus 2. All I need to do now is to rationalise here to hopefully get back to what I'm actually trying to prove, which hidden amongst all this mess is this. So let's rationalise. So that means I'm going to have to multiply top and bottom of this surd by root 3 minus 2. So the root 3 times 2 root 3 gives 6. The root 3 times 1 is root 3. The minus 2 times 2 root 3 is minus 4 root 3. The minus 2 times 1 is minus 2. And on the denominator, the root 3 times root 3 is 3. And the minus 2 times the plus 2 is minus 4. Which we can see the numerator then, we've got the 6 minus 2 is 4. We've got the root 3 minus 4 root 3, which is minus 3 root 3. The denominator, 3 minus 4 is minus 1. And dividing through by minus 1 will make the signs on the numerator flip. And that was the desired answer for part A. So let's now have a look at part B. It says, hence, or otherwise, solve between 0 and 180 degrees for 2 cos 2 theta plus 40 equals sine 2 theta minus 20. Now it does say hence, so I do want to compare these really carefully. We can see we've got the 2 cos X, 2 cos there, we've got the 2 cos there, we've got the sine here, the sine there, so they match up perfectly. But the inside here and the inside here don't quite match up. I'm thinking what value of x would make these things true? This x plus 30 would have to be the same as this 2 theta plus 40 in order for me to use part A to help. And then that value of x would also have to work over here as well. So let's think about this. Let's say that x plus 30 equals 2 theta plus 40. Just checking, making these two things the same. That would then mean that x would have to be 2 theta plus 10, taking the 30 away from both sides. Let me just check then that if that's what I'm going to do, would that work here? X minus 30. So if x was 2 theta, I'd have 2 theta plus 10 minus 30. And yes, that does match up with that. So if x is replaced with 2 theta minus 10, 2 theta plus 10, then I can use my result from part A instead of part B. So let's do that then. Let's replace the x with 2 theta plus 10. I can now do tan inverse of both sides. So tan inverse of 3 root 3 minus 4 is 50.1. And we'll draw a quick tan graph to get our other solutions. I'm drawing it all the way up to 360 because I know I'm going to be dividing by 2 in a minute. Okay, so there's my tan graph. I've already seen that my first solution was here at 50.1. The second solution therefore will be there. So like I say, this is 50.1. So I'm now going to do 180 plus 50.1, which is 230.1. We'll now subtract 10 from both of those. Excuse me. And then we'll divide both of those by 2. And my final answers to one decimal place are 20.1 or 110.1.